Bismillahirrahmanirrahim. Welcome everyone, and let us start a topic today, which is the salt hydrolysis. First of all, you must have an idea what is meant by the salt. Salt is actually a substance which is produced by the neutralization reaction of an acid and base. So acid and base, they react together to form salt. And you know that during this neutralization reaction with salt, water molecule is also produced. So salt is a substance which is produced by the neutralization reaction between the acid and base. Now what is meant by the term hydrolysis? Hydro refers to water and lysis means breakdown. So hydrolysis means cleavage of the covalent bonds of the water molecules. Now salt hydrolysis is a double decomposition chemical reaction. Double decomposition mean that during salt hydrolysis, the bonds in the salt as well as the bonds in the water molecule both are broken down. And actually, salt hydrolysis is the reaction of the salt with water. Now imagine, it is very simple to understand that when acid and base they react together, they form salt and water. So when a salt will be reacted with water, it will again produce some acid and base. So basically salt hydrolysis is the reaction between ions or ion of a salt with water molecules producing acidic, basic or neutral solution. This one is the definition of the salt hydrolysis. I have mentioned here ions are ion, which simply means that in some cases both cation and anion of the salt reacts with water, while in the other cases any one of the ions, whether cation or anion, that will react with the water molecule. And during this reaction with the water molecule, the bond of the water molecule will also be broken down. And when the salt and water will react together, they will form acid and base. If strong acid is produced, then the resulting solution will be acidic, and that salt will be acidic salt. But when salt and water react together, strong base is produced and weak acid is produced. It means that overall the solution will be basic, and that salt will be called as the basic salt. And if salt reacts with water and both acid and base both strong acid and strong base is produced, then the neutral solution is obtained and the salt is called as the neutral salt. So it means this one is a chemical reaction. Hydrolysis is actually a chemical change. It is not any physical change like hydration. It is a chemical change. And because of this chemical change, the pH also alters. Listen these points very carefully, because in this lecture we are also going to study the hydration and the difference between the hydrolysis and the hydration. So this was about the salt hydrolysis, that what does it mean and what is meant by the acidic, basic and neutral salt. Now let us study the salt hydrolysis in detail. In order to study the salt hydrolysis in detail, you are required to know that the salts are of four types. The first salt is the salt which is produced because of strong acid and weak base. I have already mentioned that salt is a substance which is formed by the reaction of acid and base. So there are some salts, when they are produced, acid is strong and the base is weak, that react together to produce that salt. So this one will be the first category of the salts. Now the second category is in which weak acid and when strong base react together, then salt is produced. Third category is the one in which strong acid reacts with strong base. And the last category is in which a weak acid reacts with weak base and a salt is produced. So these are actually the four types of the salts depending upon the relative strength of the acid and base that react together to form the salt. Now let us take their one example each. Strong acid and weak base. Example is ammonium chloride. Ammonium chloride is formed by the reaction of ammonium hydroxide, which is weak base, and HCl, which is strong acid. The second category is weak acid and strong base, like sodium acetate, which is formed by the reaction of weak acid, acetic acid, and a strong base, sodium hydroxide. Strong acid and strong base, very common example, that is NaCl. And weak acid and weak base, one of the common example is ammonium acetate. In which case a weak acid, acetic acid, and a weak base, ammonium hydroxide, react together to form four types of the salts. Now this is very simple, that a salt which is produced by the reaction of strong acid and weak base, when this salt will be dissolved in water, it will again produce strong acid and weak base because it is formed from these species. So this salt should be acidic salt. Means when this salt will dissolve in water, it will form acidic solution. Now this is a salt which is produced by the reaction of weak acid and strong base. So when this salt will be made to react with water, it will again produce the same species from which it is produced. It means strong base will be produced. So this salt will be basic salt. And the pH of its aqueous solution, that should be greater than 7. And the pH of the aqueous solution of ammonium chloride, that should be less than 7. Strong acid and strong base. Keep in mind that the salts which are produced by the strong acid and strong base, when they are dissolved in water or they are made to react with water, they also form strong acid and strong base. So overall solution should be neutral. And actually we say that these salts form neutral solution, their pH is equal to 7, and these are the neutral salts. And when weak acid and weak base react, again when this salt will be made to react with water, it will form weak acid and weak base from which it is made. So its solution should be neutral solution and having pH equal to the 7. So some salts form acidic solution because they are made of strong acid. Some salts form basic solution because they are made from the strong base, and the other salt form the neutral solution because either they are made by the neutralization of the strong acid and strong base or weak acid and weak base. Now we are going to discuss, first of all, look at this very carefully. Now we are going to discuss that how the hydrolysis of these salts actually takes place and how do they react with the water molecules. So let us move into it. First of all, let us take example of ammonium chloride. When ammonium chloride dissolves in water, it forms ammonium ion and chloride ion. Listen very carefully. That chloride ion is a weak conjugate base because its acid HCl is strong. You know that whenever an acid is strong, its conjugate base is weak, and whenever an acid is weak, its conjugate base is strong. If you do not have any idea of it, then kindly first of all watch my lecture on the ionization constants Ka, Kb, Pk and Pkb. Then you will be able to understand it in a much better way. So it is a weak conjugate base, and the weak bases, they do not react actually. So it will not react with the water molecules. But this ammonium ion, it is a weak conjugate acid. Why? Because its base was, it is a strong conjugate acid because its base was weak, ammonium hydroxide. Now it will react with water. And what will happen? It will take H positive, it will take OH negative from water. And it will form ammonium hydroxide. When ammonium hydroxide weak base is formed, what then remains in the solution from water? That will be the H positive ion. So this solution will be rich in the H positive ion, and a solution which is rich in H positive ion, that will be acidic solution, and this salt will be the acidic salt. Let us take another example in which sodium acetate gets dissolved in water. Now it forms sodium ion and acetate ion. Now sodium ion is a weak conjugate acid because its base was strong, but this acetate ion, that is a strong conjugate base because its acetic acid is a weak acid. So in this case, this will not take part in the reaction hydrolysis, but the acetate ion will take part. And when acetate ion will react with water, they will accept, because it is a base, so it is a strong conjugate base, it will accept proton from water and it will form acetic acid. And in the remaining solution, there will be OH negative ions. So the solution which will be rich in OH negative ion, that will be overall basic and its pH will be greater than 7. And this salt will be the basic salt. Now let us take example of the third case in which NaCl is there. Dissolve NaCl in water, you will get sodium ions and chloride ions. Now sodium ions are weak conjugate acid because they are produced from strong base sodium hydroxide, and chloride ions are weak conjugate bases because they are produced from the strong acid HCl. So both of these, they do not react with water. In this case, there will be no hydrolysis. Listen very carefully. Any salt which is produced from strong acid and strong base does not get hydrolyzed, and its overall solution, that will be neutral, having pH equal to 7. So this is a very important MCQ, that which of the following salt does not get hydrolyzed. You will have to find the option in which a salt is made from strong acid as well as the strong base. Now let us move towards the last one, and that is ammonium acetate. When it will be dissolved in water, it will produce ammonium ions plus acetate ions. Now both these are strong. It is strong conjugate acid, it is strong conjugate base, because both of these are produced from the weak acid and weak bases. So they both will react with the water. And when they both will react with water, what will they form? Ammonium ion will combine with negative part of the water, forming ammonium hydroxide. And acetate ion will combine with positive, forming acetic acid. And as both these are weak, so again the solution will be a neutral solution. So those salts which are, but keep in mind there is a difference between these two. A salt which is made from strong acid and strong base does not get hydrolyzed, so its solution is neutral. But a salt which is made from weak acid and weak base, that gets hydrolyzed and it produces the neutral solution. So there is difference. No hydrolysis and neutral solution. Hydrolysis takes place and the solution is the neutral one. This was the hydrolysis. Hydrolysis is a chemical reaction in which new species are produced, just like the hydrolysis of sucrose. In the hydrolysis of sucrose, the glycosidic linkage between the glucose and fructose breaks down, as well as the covalent bond of water. They also break down between hydrogen and OH. And as a result, what is produced? Glucose and fructose, they are produced. Hydrolysis is totally a chemical change. It is a double decomposition reaction in which the substance undergoing hydrolysis also undergoes cleavage of the bond, and the cleavage of the bonds of the water, that also takes place. Now let us move towards the next part of this lecture, that is the hydration. So what is meant by hydration? First of all, let me tell you one thing, that hydration is a physical change. It is not any chemical change. During hydration, no change in pH. There is no change in pH of the substance that is hydrated. So, no, please recall in your mind the important points of the hydrolysis that I have just mentioned. That hydrolysis is a chemical change, but hydration is a physical change. In hydrolysis, the pH of the substance is changed, of the solution is changed, but in this case there is no change in the pH. Now, what is hydration? Hydration is actually physical attachment of water molecules with salt usually during crystallization process. So that is the physical attachment of the water molecules. When a salt is, or the pure crystals of a salt are prepared from its aqueous solution, then some of the water molecules remain in attachment with the salt, and they are called as the water of hydration, and this process is called as the hydration process. For example, in case of blue vitriol, there is copper sulfate dot 5H2. Now these 5 water molecules are physically attached to the copper sulfate, and this is called as the blue vitriol. This water molecule, these 5 water molecules are called as water of hydration or water of crystallization. So tell me one thing, is there any chemical reaction that has taken place here? No. Simply copper sulfate was anhydrous and 5 water molecules they have physically attached with the copper sulfate, and from anhydrous form now this substance is changed to the hydrated form. So there is no chemical change, there is no chemical reaction, simply physical attachment of the water molecules is there. And these water molecules are called as the water of crystallization or water of hydration. Now in case of copper sulfate, when we perform some calculations, it is seen that with copper ions there are 4 water molecules which are attached, and with sulfate ion only 1 water molecule is attached. And total there are 5 water molecules which are attached to it. Now question arises that why? First of all, let me tell you one thing, that these 4 water molecules are attached to the copper ion through coordinate covalent bond or dative bond, and this 1 water molecule attaches with the sulfate ion through hydrogen bond. So there are total 5 water molecules that attach with it. There is a question that why more number of water molecules attach with the copper ions and lesser number of molecules attach with the sulfate ion. So that is totally related to the, let me tell you one thing, that water of crystallization or you can say number of water of crystallization attached to any ion, that is directly related to its charge and inversely related to its size. And the ratio between charge and size, that is called as the charge density. So greater the charge of an ion, more number of water molecules of hydration will be attached to it, and lesser the size of the ion or smaller the ion is, greater number of water of crystallization will be attached to it. Let us see what's about copper ion and sulfate ion. Now the charge in both cases, that is same. Magnitude is same, sign is opposite, but we are just talking about the magnitude. Magnitude is same. It means charge is not the primary factor which is responsible for the different number of water of crystallization which are attached to the copper and sulfate ions. What will be the key factor then? That is the size of the ion. Now you know copper is a simple monoatomic ion, so it is of smaller size, having high charge density because inverse relation is with the size. And this one is a polyatomic ion, obviously it will be larger in size. Its E by S stat will be very small. So that's why due to low charge density, less number of water molecules surround sulfate ion, and due to high charge density, greater number of water of crystallization are attached with the copper ions. There are so many other examples of the hydrated salts, just like you can say Epsom salt is there. MgSO4.7H2O. Similarly, there is oxalic acid, and that is in the dihydrate form. There are so many other examples, etc. And keep one thing in your mind, that these water of crystallizations which are attached to these salts, they do define their physical properties. Like you know that CuSO4, if it is anhydrous, then that is white in color. But when water molecules get attached to it, it becomes blue in the color. And there is also a formula which is used to find the percentage of the water of crystallization. So percentage of water of hydration, that is equal to mass of water molecules divided by total mass of hydrate multiplied by 100. Just like in case of oxalic acid, what should be the percentage of water of hydration? Mass of water, because two water molecules are attached, so that will be 36 divided by. Now what should be the total mass of this hydrate? 12 plus 32, 44 plus 1, 45 multiplied by 2, 90 plus 36, 126 multiplied by 100. So simply solve it, whatever will be the answer, that will be the water of percentage of water of crystallization. So this is a way how you can find the percentage of the water of the hydration. So in this lecture we have studied what is meant by a salt, what is meant by hydrolysis, then what is meant by salt hydrolysis, how the acidic, basic and neutral solutions are produced by the salt hydrolysis, and how the hydrolysis and hydration, they are quite different from each other. I hope so that this lecture will be informative for you people. Take care. Allah Hafiz.